So this section has been a little heavy duty. We have talked a lot of things. We started with Catalyst Optimizer and how Catalyst Optimizer works and what are the various steps of Catalyst Optimizer, starting from unresolved logical plan, then resolved logical plan, then optimized logical plan, then the selected physical plan and code generation. After the code generation is done, it is sent to Tungsten Execution Engine. We have also seen how Tungsten Execution Engine helped Spark increase the performance. Then there are internal joins. We have talked about sort, merge join, broadcast has join, broadcast nested loop join, shuffled has join, and shuffled nested loop join. The most optimal is broadcast has join, and the least optimal is shuffled nested loop join. SNLJ is also called Cartesian product. Then we have seen multiple physical plan operators like hash aggregate, sort aggregate, collect limit, etc. Then I had shown you explain plan and how you can read the explain plan output, which is similar to what we see in the Spark/data frame tab and the DAG output in that tag or the DAG visualization in that tag. There are various options that can be passed in explain plan, but in most of these cases, we'll be using the DAG in Spark UI, unless you want to take some proactive measure by looking at the explain plan. Then we had seen a long-standing problem of Spark, which is called data skewness. And data skewness is still relevant. We still see data skewness in a lot of scenarios. But you know how to solve data skewness. One of the options is salting, and the other option is adaptive query execution, which automatically splits the skewed partition or the skewed join. There are other features available in adaptive query execution also. For example, dynamically changing sort merge join to broadcast has join depending on the parameter. Then it can coalesce the shuffle partitions also, that too dynamically. Then there are two more dynamic features that we have seen. One is partition pruning, which is available to Spark by default, and it is only applied when the dataset is partitioned and the partitioning column is used in the where clause or where API or filter API. Then we had seen dynamic resource allocation, which can be used to increase or decrease the resources that are available to a Spark application. So that's about it. We have talked a lot of things, and this is where I conclude the Spark concepts. Going forward, I'll be talking about databases, data warehousing systems, files, etc. But the concept should remain the same. And a little request about saving animals. As you know that we need animals more than they need us. And because of global warming, because of explosion of human population, we are actually snatching their habitat. Of course, we cannot go and fix everything, but the least we can do is save animals in other way. For example, do not buy any leather products. Do not buy any products which contains animal skin, animal bones, or any animal part. So if you do not buy those, obviously the animals will not be killed and we'll have a better world. Coexistence is something that nature has given us, but we humans are destroying it. Let's try to restore that. That's a small request from me. Please try your bit to save animals. Now we come to super summary. Here I'll be talking about all the things that we have discussed at a very high level. I started with Spark batch processing and stream processing and what is Spark's role in batch and stream processing. Then I talked about Spark ecosystem wherein there are multiple components and it starts with the Spark core API, that is RDD, or resilient distributed dataset. And then we have DataFrame API, and on top of DataFrame API you have Spark SQL. I have not talked about RDDs or Spark SQL yet, but DataFrame API is something that I have spent most of the time on. I'll give you an introduction of RDD in later sections, and definitely I'll talk about Spark SQL. But Spark SQL is based on top of DataFrame API. And if you look at the Spark documentation or Databricks documentation, you will see that as a best practice, you should always use either DataFrame API or Spark SQL. You should not use the core API or RDD. Then I also talked about hosting platforms like AWS EMR, Databricks, and Google Cloud's Dataproc. So these are the platforms where we get the clusters as a managed service and you can execute our Spark application there. Then I talked about execution architecture, like Spark has a component called driver and there are multiple components called executor. Whenever we submit an application, Spark session is actually the driver which communicates with the resource manager. And in case of EMR, it is Yarn. We have also used standalone resource manager. So driver communicates with the resource manager asking for the number of resources, which is nothing but executors. And then the resource manager creates those many application containers. And then the executors are launched there. Then you have also seen various Spark deployment modes like standalone mode, cluster mode, and client mode. So far, I have shown you only standalone mode. Next section onwards, I'll show you cluster mode on EMR and Databricks and client modes like notebooks. Then I went deeper into Spark concepts. I started with data frame, then various file sources and targets, and how we can use data frame reader and writer to read data from file sources and write to file targets. We'll be using data frame reader and writer for other sources and targets also, like relational databases, NoSQL databases, or data warehousing systems, lake houses like Iceberg. Then I introduced you to shuffle process and how the external shuffle service is paramount in executing the entire shuffle process. And when you talk about shuffle, there are shuffle partitions. And in Spark, there are three types of partitions. One is the input partition, then you have shuffle partition, and then you have output partitions. We have also seen how we can change the input partitions, shuffle partitions, and output partitions. Then I talked about data frame, partitions of data frame, and how tasks, jobs, and applications are related to each other along with the executor. And whenever we use any action, then only the Spark application would be started executing, which is called as lazy evaluation. And the transformations will not execute anything. And there are two types of transformations. One is narrow and the other one is a wide transformation. As I told you that I had talked about the shuffle process and how external shuffle service helps in that shuffle process. We have various write modes like overwrite, append, ignore, error, etc. Then you went into a very important topic with Spark memory management, wherein I told you about the memory footprint, the CPU usage, how to decide the size of the cluster, meaning what should be the number of executors, number of partitions, number of tasks, and the amount of memory that would be needed for a single Spark application. And you can extrapolate it to any Spark application that you have. Then I talked about on-heap memory, which is nothing but the executor memory, and off-heap memory, which is outside of the JVM process. And each executor in Spark is nothing but a JVM process, including the driver. There are various memory areas like reserved memory, execution memory, storage memory, and user memory. When you talk about execution and storage memory, execution memory can use storage memory if available, the entire storage memory, and storage part can use execution memory if available. The storage part cannot consume the entire execution memory because it is something which is needed for Spark's execution. And this particular process is called unified memory management. Using this, Spark can leverage the unused memory from the storage side or the execution side. Then I had also discussed about garbage collection and how it is an overhead for any JVM application, including Spark. And then I went deeper into Catalyst Optimizer, Tungsten Execution Engine, various Spark internal joins, which are nothing but the joins that are used by Spark when we use inner join, outer join, left outer join, right outer join, etc. We have also seen various physical plan operators which can be seen in the Spark UI in the SQL and data frame tab. And of course, they explain. Then we talked about data skewness and how we can solve data skewness using salting, which is a very tedious process to fix the data skewness problem, or actually fix the processing problem emanating out of data skewness. AQE, dynamic partition pruning, dynamic resource allocation, these are new features of Spark which are useful in improving Spark's performance. And these are the transformations, actions, functions, and window functions that I talked about. I'm not going to talk about all the transformations or APIs. If you want me to cover other transformations or other actions, please let me know. I'll put that or I'll put those in the video. That's all about it. And as I said, this is where I conclude Spark concept sections. Next, it will be practical sections. Thank you.